Okay. Actually, I opened my SQL server. I've opened my SSMS. So that is what you can see. And within my SSMS, really, there are quite a few features which you need to familiarize yourself with. I'll start basically with this window, which is this drop down, and this will be where you can find all the um, databases which are installed on your instance of the SQL Server that is installed. Okay, like you have this DW and the ones with the DW and the master up to here, they are actually system generated database. It comes with every installation of SQL. It comes with every installation of SQL. So, and they are, we call them system databases. So you don't really need to do anything with them. Though at some point later on, you can begin to interrogate your master, depending on what you're trying to see. Because everything we do on our server here is actually recorded in the master database. And also we have the temp DB here, which is stand for temp database. This also is where all your current working, the sessions you have opened, this is where they are stored as well. That's where they're kept. And you can go into the temps as well if you have the right knowledge. You can go in and interrogate your temp database to see what has happened to some of your data or your objects within your database or within even your server as a whole. Okay. Now, these databases which I've mentioned, they are global databases that relates to all of the databases that are on your server. But as you begin to create your own database or you begin to restore databases on your server, right, they are standalone. They are standalone. Like this database is not related, sorry, this one is not related to this one, right? And neither is this one related to any other one except for them relating back to the master and the temp. Sorry, and the temp data, the DB. Okay. Now, that is the first bit. And then when you connect to a database, the database name will be displayed here, which is what we have currently. This is the available databases. And then you can now see I have my server name. If the first part here is your server name, right? And also the person that logged in. If you look at the pop-up that is coming, that's showing right now, you will see at the end, it has one vine edge backslash ODBAL. That is my login from my from my um, from my laptop. That is my login. So there's always the requirement for security to be granted to you within that database for you to be able, even within the server first, and then in the database for you to be able to access them. Okay. If you're not granted permission on the server level, you will not be able to access the server. One. Two, even though you are granted permission on the server level, you are not granted permission on the particular database, then you cannot access it as well. Okay, so I'll quickly show you one. Here I have databases, right? It will list my databases as you are seeing from the drop down. The same thing is showing here, but you can see here there is the system ones have been put into the system folder, and that is where you find them. See the system databases, all these ones, they're system databases. So they are just taken away out of your view because you don't really need to do anything with them if you are not the DBA. Okay. And then you have the snap databases. If you have a snapshot database, which is we take an instance of the data as at a particular time for reporting on anything, you can do that. And with that snapshot you take will be saved here. Okay. Well, these are now your live databases. Okay. This diagnostic and you say configuration, they're still part of the system databases because I don't need them, but they're kept here and you can see what is here is not something that is of any use to me. for now, but it is just the system. Okay. There's just another one, which is the DW configuration, stands for data warehouse, but we currently do not have any data warehouse resident on this server. Okay. So anything DW is still part of that category. All right. Now the security which I was talking about, I'll show you a little bit about it. Right. You see here when you come to security, sorry, you come to security folder here, and then you can see here, I have the logins. You can see my login that you saw earlier when I did that, and that is my login because now I have been granted access to this server. That is where I've been granted access to this server to be able to access this server. Okay. And then there's one built-in user as well, which is called the SA in SQL, which is system administrator or SQL server system administrator. That is, but in my case, I'm not using that because that we found out most organizations that don't use this, and the reason why they don't use this is that it gives easy access to hackers to hack into your database. When you use this, it's very easy because it's something that comes with every SQL Server database or yeah. So most of the time we don't use it. You rather create a new user, which is you're going to grant the admin rights. Okay. If I open this, and let me see the properties here. And you can see it's still showing my name there. And the access, you can see here, it says here, my default database is the master, and that is the system database. Once I'm granted access to the master, I can access everything I can see everything. Though that does not still give me permission on each of those other databases. So just give me access to the whole of the server. I can log in, I can see it, but it does not mean I can access the databases, individual ones. I need to be granted access or permission in each of those databases as well. Okay, so now I have the master, and you can see I can change any which one to be my default database. I can change it to this, I can change it to this, I can change it to anyone. But as standard, it is always the master for someone who has got the admin right. I repeat, you have got the admin right. Okay, so now you can see the server rules. You can see here, I am granted also this one, the sysadmin. That means I've got the system administration. That means I've got the overall admin on this server, overall admin. You can only be granted, sometimes you can just be granted public for people who just need to access this table, this database and do some view it. You can just grant them what's it called? Public. So, and then for people who will be doing the backup and all the stuff like that, they need to grant them the disk admin or the DB creator or bulk admin and stuff like that. But once you have the sys admin, it overrides any of other these ones. You have the ultimate permission on this server. Okay. And then you can see here as well, you see all the databases that master has been targeted to, and I can increase it as I want as well. I can add that as well. You can see these ones are by default. Now I'm having me, right, as administrator on this one. I can do this one and this one as well. You can see it changes, but for now, I'll just leave it the way it was. Okay, and I've been granted a partnership. And here I have the overall permission. You can see here it says what? I have at the server level. I have that permission at the server level. And then here you see I've been granted. If my login has been created as it is, and I want to say, okay, you know what? He's not going to be around for some couple of months and so, and we don't want any tampering and everything. We can revoke the permissions, not deleting the user, but I can revoke the permission up until such time that we need he or she is back and we can restore back that permission. So if I click on deny, then it disables it. Or I can now come in, even if I don't do the deny, I can just disable the login, and then he or she will not be able to log in. Okay. And then on the database level, let's look at the Northwind, right? At the Northwind level, you see each database has got its own security as well. So coming to that database and I come into users, and here you have, because I have the DBO right, I've been granted that is my username. Sorry, yeah, my username as is been mapped to the DBO. So I do not need to, they do not need to create me specifically again in here. But because I've been granted the permission on the schema DBO, which means stand for database owner, then I can access this database as well. Okay. And if I go to the properties, there won't be much there because I've just inherited that permission. And you can see here on that schema, it's that schema that's been granted, and you can see the membership as the owner as well. So that covers that. And the same happens for all the other databases as well. If you come back in here, you have the security as well. You have the users. And if I expand on the DBO, it's the same thing, right? You can see SQL Server without login type, okay? And you can see I've been granted the same, the schema and the membership and the owner as well. All right. Any questions before I go ahead? Right now, okay. Now the question is, what is even SQL? What is SQL? SQL stands for SQL Query Language. Stands for SQL Query Language, which SQL Query Language. That's what SQL stands for. Okay. Oh, I didn't even say it stands for SQL Query Language, and then it lets you access and manipulate databases. Okay, SQL lets you what? Access and manipulate databases, like what I've just explained to us. Okay, and then SQL became a standard, which is the American National Standard Institute, ANSI, we call it ANSI, and in 1986. And then it became the standard for the iOS, International Standard Organization, in 1987. And currently we have different variants of SQL. We have T-SQL, which is the SQL for Microsoft products. T-SQL is for Microsoft's products. And then we have the PL, that is procedural language SQL, which is the SQL variant that is used in Oracle. And then also we have another variant of the T-SQL, which is used on the IBM server as well. In this case, we call that the M3. Okay, and this is, there is a two variants of that as well. We have the M3 and we have the Netezza as well. But the Netezza is actually being now sort of merged, is fading away. Is because Netezza was another variant of SQL before, or server, but then IBM bought over Netezza and then blended it. So Netezza technology is now what is in IBM databases, like the DB2, which is the IBM database. Okay, he said, what can SQL do? SQL can execute query against a database. SQL can retrieve data from a database. It can insert records. It can update records. It can delete records. It can create new databases. It can create new tables, and can create stored procedures, views, and also permissions on table procedure and views as well. All right. So that is what SQL can do. But this is just an overview. because what each of these line does is quite enormous. I cannot even finish it in 20 days even. Okay, because when you talk about execution or executing queries alone, there are quite a number of things that goes on from the start to the end and in the middle as well. Especially when you talk about the processing of that query, the cost of it and all the stuff like that. We use the cost, not really the monetary cost, but then I don't know why they use the term cost, but it's the cost for executing that query. So it's just the cost of you going from A to B. The energy that you have expended in traveling from A to B, we want to know if it is worth that energy, or there's a way we can actually reduce that energy or that cost if there is a shortcut to get to what we want. Okay, and then the same thing goes for retrieve and inserting of records and all this stuff. As much as possible, I will want to touch on most of these ones, especially from the execution of the query up to writing a view or creating a view and so forth. And even if possible, if time permits, stop procedure, and then we'll explain better to you. Okay. Now that takes us to what is actually RDBMS. RDBMS stands for Relational Database Management System. Our SQL server is a relational database management system. Okay, because why? How does that work? What do we mean by relational? What we mean by relational is that there is a connection between objects that are in the databases, which I'm going to get to very quickly. Okay, there is a relationship. Okay, I'm going to give you an example very shortly. Okay, it says RDBMS is the basis for SQL and for all other modern databases such as MSQL, which is what we're using now. We have the IBM DB2, we have the Oracle, we have MySQL. Even Access Database is also a relational database as well. Okay, so it says the data in the RDBMS, whatever, is stored in database objects called tables. So the first basic structure within a database is a table. That's the first thing, really. You don't have a table within a database, then you can't do anything, because that is where the data you have stored. That is where it's going to be stored. You have stored. That is where the data has been stored. Okay, the data you have ingested or the data that has been processed and kept, they will be kept in the table. Without a table, there's no database. And so the table is a collection of related data entries, and it contains columns and rows. Okay. Now I'm going to, let me see if I can have that. I have an Excel open here. Okay. Let us use this. I think we are all familiar with Excel, right? Okay. You see here, this is an Excel
Yes,
spreadsheet.
sir.
Okay, good. This is an Excel spreadsheet. Okay. But you find out that this data, if you look at each of the tabs below here, you see the first one says sales order, the other one says regions, and then regional budget, then custom and client budget, and you have the product budget. But you see this. Yes, Excel is a form of a database because it stores this information. But then Excel is a flat database. And the reason for it being flat is that there is no much of relationship. Yes, in this spreadsheet, we've tried to create a relationship, okay? And you look at it, the columns, it says, what is a table? this worksheet is just a typical example of a table in a database. Okay, if you look at the top here, the headers, I have the order number, I have the order date, I have the customer code, I have the customer name, I have the customer type, the currency, the warehouse code, the delivery name, delivery region, order status, product description, order quantity. And you can see that all of these columns, they're actually information that relates to a transaction. They're all information that has been gathered that relates to a transaction. This information is what you can use to describe a transaction. Take, for example, you went to Tesco and then you went through the aisles and then you picked a bottle of Coke, you picked a pack of crisps, and then probably you picked biscuit as well. These are the items that you have gone in to purchase. First, for us to be able to make sense of this, just to say, okay, we had a sale. That is just the top of it. But then for you to be able to study this information, first of all, you have to store where's the location of the store. You have to put the store, you have to have the store location. Okay. Now, what product? You need the product information. Okay. So, and then, and when you get to the till, who is it that attended to you? Did you go through the self-service or you went through a cashier? Right? And then you, the customer as well. Okay, so this information is what we are interested in. And the reason why we're interested in this is because for us as data engineers and business intelligence, we want to be able to draw inference, run analysis and draw inference to be able to make informed decision. But without this information, we are not able to draw any inference. We're not able to even run any analysis, not to talk of making an informed decision. So you look at it, a table is an entity within a database that is a collection of related information. It could be about a product, it could be about a store, it could be about a transaction. Like this one, sales order is a transaction table. But if you come here, regions, this is just about location. Because here you can see that is just the ID for each of the cities. But now you have city, you have the city in a country, and in fact, it should be the other way. But then you have a city in a region, in a country. A city in a region, in a country. And we can still break this down as well. Instead of just the city, we can even go to locality as well within the city, if we want to. And then within the locality, we can even go to, like we in the UK, you can look at a certain postcode as well. And within that postcode, you can now look at a particular property. Or you can look at a particular neighborhood. So this is how granular the data we collect in the table can go. All right. So now, this sales order table, we have made it relational. And the reason why I'll say we made it relational is that you can see here at the end here, we have this Power Apps ID. And this Power App ID has been repeated in all of these other tables. And that makes it relational. So I can from here, say this is the client budget. I can from here, let me say, copy this and come into sales, come into this column and do a find. Do a find. And I paste that which I did. I say find. Okay, it's not here. Should be. Let's look for another one from here. Copy that one. And use, and I should be able to, I can find it here. Let's look at here. Find budget. And I should be able to find it. No, there should be a relationship. Okay. There should be a relationship between them. Yeah. You can see, yeah, it's found it now. Look at that now, and then you can see the value. So that is creating a relationship between them. Now, that's it. So we have tables as our first entity within our database. Now, when we have a collection of tables, and then we now begin to say we want to, we're not even getting to the side of the processing, but what we as data analysts or data engineer, as the case may be, or BI developer, as the case may be, we do first of all is now we begin to see to massage the data, because more the data we as data engineer and analysts and all the stuff where we will be working with, we are not the one that will generate the data. The data is coming from the business, and the business data, you look at it, like I will use Tesco again. When you go to Tesco and after the you've gone through the ad and you've selected all the products or items you want to buy, you go to the till, either a manned till or a self-service, right? And you scan all the items through the scanner, the POS, and then you get a sum total, and then you make your payment and you leave. As we are scanning each time, that scan is recording in a database, in one or many databases, depends on how the stock or the architect of that system is. Because sometimes it's just not one database, it might be multiple, because they may have a separate database for the product and all the stuff like that. But I won't be going into that. So it's recorded in at least one database. And within that database is in one or many tables as well, depends. Okay, so this data is already there in the operational system or the business system. They're already there. But you as an engineer, you as a data analyst, what your remit is that you now have access to a copy of, not the live one, not the one that we're using for our day-to-day transactions. No, because what we are trying to do is to take that data and massage it, manipulate it in whichever way, and begin to do the processing, and then we'll be able to provide insights that can be used for decision making. Okay, so what happens is that you as a data engineer, you will need to take a copy of that data. It may be you or maybe some other person, but the copy of that data will have been what you have access to, and you can begin to do what you need to do. Okay, so the data is already in situ for you. You're now having to now access the data, and based on the business requirement, you begin to develop. Okay, in some cases, you might be the one that will develop the data warehouse, and we call it data warehouse because we're bringing data from many different sources into one storage. Okay, so you might be the one that will have developed the data warehouse, and if you already have the data warehouse, then you will now want to create an insight, or you want to you have a business requirement to create a report or to create an analytics or something like that. Then you have to create your script, and that is where SQL comes in for you, right? And that is where, in some cases, Python comes in, and PySpark as well. And when that is done, you need to present this data or this output to the business, in a visual form, and that is where Power BI comes in. Okay, so now we have our database, we have the tables within it, and then we now have what is called our SQL statements. And our SQL statement is just the code that we write that interact or interrogate the data, underlying data in our tables, and present to us a result or a result set. Okay, it says SQL statement. Most of the actions you need to perform on a database are done with SQL statements. Okay, and then the following SQL statements select all the records from the customer table, which is this statement. You see here, I have select. You can see it's in blue. Any word that you see here that comes out in blue means that it is a reserved word in SQL. It is a reserved word in SQL. Like select is a reserved word, from is a reserved word. But what this statement is saying basically is just this. It says, go into the table that is called customers, and fetch me all the rows, all the records, all the rows that are in that table, and present the results to me. Give me every column, every row in that table, and give me a result of it. Okay, and this star, which is you get that star from by pressing your control and then your letter 8. You see it's on the top of your letter, your keyboard, letter 8. So, but you need to press your control to be able to activate it. So press control and then the letter 8, then you have your star. We call it star. So here, because it just looks like a star. So it says here, select star from customers. So it says, look, select every column rows from the table customer. That's basically what this does. And if I execute this, for you to execute, you see, because I have so many things here, so I need to highlight, and then I press my execute button here. There's something, let me see, what's that? Okay, let me press this. Okay, because you can see it's gone into that table and has returned back all the rows. All the rows. And here at the bottom, look at where my cursor is at the bottom. That is where you will see at the bottom right. That is where you will see the total number of rows that has been returned based on this your query, your statement. Okay, that's everything. And you can see this is all the columns. And if I go into my database, which is here, let me use this one. And customers, if I expand, you see here, that's my customer table. If I press, click on this plus sign, it's going to open, and then you see it says columns. And here I can see all my columns. And if I come here, you can see the first one here, customer ID, and that is customer ID, company name, and the last one is the email address, and that is it. So it's returned back all these columns, and then the rows is where the data is stored. Particularly, the column is the collection category, which is in this case is just the ID, and in this case is the company name. Okay, and the rows is just where the records, the data is actually stored, and the intersection with this and that is one tuple. But I won't be going into that right now. So you have that. Okay, it's returned back everything. But then sometimes, because of what we have these days, we have terabytes of data. when I mean petaterabyte, it's 1 gig of data in one, is it gigatrillion or something? Trillion. That is one. And because of the cost of storage these days is become relatively cheap compared to previously, we are able to store so many data points, so many. Like now, let's take your mobile phone, for example. Your mobile phone speaks to a mast at almost every second or every minute, right? Because it has to make contact with the mast. And that is a data point. Each time your phone is contacting, that is a data point. And each time you're receiving messages or text messages or WhatsApp messages, it's stored somewhere. Each time you're talking to someone, it is stored somewhere that okay, there is a call between A and B at this so time. The call started at this time, the call ended at this time. And then your operator will be able to say, this is the cost of this call, right? And you will record your location, you will record the other party's location as well, so that you know, okay, you're calling somebody from the UK in Nigeria, you're calling somebody in the UK from Nigeria, or you're calling somebody in the US from the UK. It stores all those information. And that is why we have so many big volume of data. Especially telecoms, they store a lot of data. Okay. Now, so there are times when even to retrieve all the data to use a selector in a table is going to take hours for the result sets to be processed and then delivered to you to be displayed like this. So in that case, and you probably, it's not probably, you don't even need to see all the records in the table at every particular point in time. You only need a subset of that table, of that data to see and to do what you need to do. And that is where we now begin to filter down. Okay. So if I open this, you see here, it says, let me even go through this. It says the select statement. The select statement is used to select data from a database. The data returned is stored in a result table, which is like what we have now, and it's called the result set. And the syntax is always like this. You put your syntax, which is, you can now say, like I did here, I did a select, which is select every column and every row. This is my column. I'm sorry, the header here, this is my column. The one where you see the customer ID, those are my columns. And the rows are these ones. Row 22, row 1, row 3, row 4, because that is why, sorry, I said that is where the information for each column is stored. Some columns may not hold information. Like this one, the facts, there's no information. That is why it is null. Like this one, this null means there's no data stored in here. This is just the system default that is placed in there. Okay, so you do your select, you can list your columns if you want, which we're going to get into. List your columns, and then you can now tell it the table name so that it knows where it is going to select from. You're just saying, okay, go to go to Downing Street. Okay, and in Downing Street you have 1 to whatever, but we know that the Prime Minister's residence is 10, and then the Chancellor is 9. So you say, go to Downing Street, select, bring out all the mail, right? Bring out all the cats, bring out all the dogs. But from where in Downing Street? That is why you now said, okay, from number 10 Downing Street. So you've given the instruction of what and what to return back to you. You want this messenger to bring to you, but you have to tell it from where. You cannot just go to any random house and bring out all these things. You can be sued. So and he or she may not even have access to enter that place. So that is why you have to specify, and that is why the from clause here does, and then you present the location, which in this case is our table. Okay, so now let's do one quick exercise. It says here, rather than do a select, I'm now doing selecting, I'm listing my columns. In this case, I say select customer ID. I want to see the customer ID. I want to see the company name. I want to see the country from my customers. But I want to bring out something here quickly. You see, when you are listing your columns to be selected, right? Each column you have to separate from the next one by a comma. You have to separate each column by a comma. Okay? You can decide to have your comma on any side as you may wish. Let me do this another version for you. There's two versions we have of variants. Okay, copy paste. Okay. Now, this one I decided to put my comma on the right, and then I did the customer ID, comma, company name, comma. But then you see the third column, the country, I did not put a comma. You do not put a comma when your comma is on the right, on the last column, before your from. When it's on the right. I repeat, when it is on your right, you do not put it on the last column to the front keyword when it's on the right. Okay, it flows in straight from into that, and from the last column into your from. But if you are putting your comma, which you can put it on the other side, when you're putting that, it's just that you're bringing this down here, you're bringing this down here, which is the comma that was here, I can put it here. Okay, and the comma that was here before, I can put it here. Okay, in this case, you see it's not giving me the right. If you see the wiggly line, let me put a comma here. You see, it will give me a wiggly line. So you see straight away, it says something is wrong. It said incorrect syntax near from, because I put in a wrong syntax. So I take that out and then it corrects itself. Okay, if I do the same for this as well, it's going to give me the wiggly line. Yes, you can see. So take that out as well. So this is just the same, it's the same query. This is not a query. This is the same query as this. It's just the place in my preference of where the comma, where you place the comma is different. If I execute this, it's going to return the same result set, which is also 96, you can see, but it's only returned back 3 columns rather than every column and every row, right? And the same thing is this one. It's going to return back the same thing, the 3. There's no difference, okay? Now, do we all have our SQL Server opened and the ISSMS?
Yes, sir.
Okay, I'll give you 1 minute just for you to do this. I'll take this out. Okay, can somebody complete this for me?
Just a quick observation. I also realized you didn't use the asterisk in this case. Is that?
Yeah, I told you the difference. In this case, I said we are listing the columns now. This is here. We're listing, it says return back all. This stands for all, right? And that is why, you see, when I run this, it returns back every column, which is what is here. But here, we are now selecting the columns we want to see. We don't want to see everything like it is here. We only want to see just these 3 columns. So for you to see these 3 columns, you have to specify. You cannot use all anymore.
Yeah, that's clear. Thank you.
Okay, so can somebody complete this? What is missing here? This exercise.
Select.
Say that again.
Select is missing.
Select.
And the column.
Yeah, but you can look at it. I have a star there.
Okay, so select is missing.
Okay, good. All right. Please, you're getting me. All right, the next quick thing. We're going to the next thing. It says we want to do a select distinct. And what does this select distinct does? It says the select distinct statement is used to return only distinct different values. Say, for example, this one would not do me justice. Okay, I'll do. Okay, look at this. Look at this column now. And then let's even use this one. Look at this column now. We have repetition in some of the rows. Like you have the sales representative on line 5. You have sales representative on line 8. You have sales representative on line 10, no, 11, and so far and so forth. And then you just want to see, you just wanted a distinct contact, like this header is contact title. So rather than you having to say, okay, you know, in Excel, let me take this to Excel. Select, copy. Let me take it to Excel. Bring it to, and I paste it in here. I paste it in here. But you can see I have 96. Okay, so if I want to now do something, I do a filter. Put it in my filter on there, and then I do a filter. I want to see only sales. Let's look for sales rep. Sales representative. I select that, and you can see I have how many? I have 17 sales rep repeated in that table. If I select another one, let's like market assistant. We have 6 market assistant. No, 5. Nigerian president is showing here. So we have 5, right? And so forth that way. And then we want to now, we only want to see every row that is represented in this column. I don't want to see the number of occurrence for each of them, like in the sales rep, it's 17 times, and in the market assistant, 6 and 5 times. I don't want to see the repetition. I just want to see the extent. So, okay, I know I have a sales rep, I have sales rep in here, I have market assistant, I have that. I want to know the number of times that they do occur. And that is what you use distinct for. Okay, I want to specify. I want to bring out that unique, right? Each of these row, yes, is represented. Even if it is one time, I want to see, or even if it is 100 times it's been represented, I want to see, but I do not want to see the number of times it has occurred. No, I only want to see that these are the total number of, or let me, in this case, these are the total, the type of job titles we have. All right, and that's what the distinct does. Okay, it said, so for us to run that distinct, we say select distinct, and then you give the column names if you're doing more than one, right? So meaning you can do distinct on more than one column from the table, okay? So in this case, do I have the distinct here? Let's run a distinct, the following statement. Okay, yeah, it will say it will remove the duplicates as well. So now let me write one statement here. And then I write select distinct. I like to use capital. You can use small letter if you want, but for me, I like to use capital. So I'll select distinct. And then my column name is contact. And then if you want to beat the system sometimes, like this, I want to, I've typed in my select, right? Even before typing in this, I type in my select, and normally we'll go to the next line, right? And type in from. And then I put my table name, customers. And you see what it's going to do for me. Because now I've set select from customer, but because I've not specified anything, that's why you have the wiggly line. But I've already specified where it is going, where the location which I'm looking at, which is customer. So now I want to do the extinct. So extinct, right? Now I want to put in, you see, once I do this, contact, you see what is going to happen? No, yeah, you can see here straight away. It's brought in for me contact name, which is this column, and contact title, which is this column, that start with these 4 letters, which I've already typed in. And why is he able to do that? Because I've already specified the table. So the engine is already looking, is know that, okay, yes, Yinka is looking at this table. And he's now making it easy for me. This is what we call IntelliSense. And then it brings that to me. So I can just double click on it rather than having to type it out fully. And that's it. Okay, and then let me execute that. And you can see it's only returned back to me 16 rows out of 96. And you can see there's no repetition. They're all distinct. Look at it. If I have owner and owner 1, it will be different because each name is unique. Owner is different from owner 1. This time. Okay, so you can see it's selected everything back to me. It's just 16 rows, right? And then I can do the same thing for city. Let's see if I have city there. Yeah. Then it's just going to select me the distinct cities. You see, there's one column or one or more columns in there, rows, right, that do not have the city populated. That is why you have the blank there. And then you can see all the cities. Okay. Moving forward quickly, it says the following statement selects all, including the duplicates, value from the country column in the table, in the customer table. So this one says what? We're selecting what? The country, and we're selecting the city. You can see it's returned by the 96. So it's just bringing out that, including the duplicate. Now, you see here, which is just the same thing here. You see here, I only did city distinct. But once I had another column to it, another filter to it, the city will not be unique anymore. It will repeat because why? I have now applied another split, which is I look at the city, right? And then, sorry, I bring the country rather. You look at the country and then it brings the city with it. So look at it here now. Look at London, UK, right? And there should be another UK location. There should be another UK location. Yeah, cows. You can see. If I have done, let's do this. Country. If I just did country, you can see here, UK is only appearing once. If I now add city to it, if I add city to this, so I'm saying give me a unique, all the unique countries, right? The uniqueness, I want that. But then now bring the cities as well. So there is a country that's got 4 different cities in the city column. Then it's going to have to bring those cities and repeat the country and the city in my result set. So look at Belgium, for example, which is very close. Look at it, it has to repeat it, Belgium and then Brussels, and then look at Belgium and Charlie Rose. So you can see that, look at Canada, Montreal, and Vancouver and stuff like that. Even look at Germany, I think Berlin, Hamburg. So it will just bring back everything. Look at the UK, right? London, America, look at how many times. Because why? This city is unique. So the uniqueness now is not just on the state, on the country, but the uniqueness is now on both the country and the city. So if there were 10 different records of, excuse me, of say, for example, US city, US Portland, US Kirkland, US Bios, or if there's more than one, right, it will only be returning one of each. But in this case, because it's just one of them, okay? And I can still split this as well, bring it even to the city. What is after the city? Let me see. Select star. I want to see if I can drill down on the city. There's nothing to drill down on. But say, for example, if I drill down city on the address, then it makes no sense because there's no point on this one. I'll call you back, I'm joining. Right? So I won't be able to do that. Okay. So the more granular you go, the less.
Sorry, sir. Please, what if you drill it down to?
Becomes. Let me finish my sentence, please. Right. Okay, go ahead.
I'm so sorry to interrupt, sir. I was just going to say, what if you drill it down to the postal code within the city? You should have.
Yeah, it doesn't become, it's no longer unique. Okay. The further down you drill down, then it becomes less unique. Right? So if you want to do the postal code, you do the postal code on its own as well. Right? Or you do it up to first, second, depends. But then at times when it is really necessary. Say for example, let me use this table. I'll open another one. Products. This is what I have in product. Select. Okay. No, it doesn't have what I'm looking for. Let me look at product category. No, it doesn't have what I'm looking for. Doesn't have what I'm looking for. Yeah. No. These are already unique. So. No. It should be. I know. I don't have what I'm looking for here. No. 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 It's not that. It's okay. But what I'm trying to say is that there are times. Okay, when I get to that place, I will explain that. Don't let me jump the gun. What I want to explain will take me jump ahead. All right. So quickly moving on. You can see because I have a comma there. Okay. So broken that. And then we can say, okay, which is what we've done here. That's just my example, which is what we've done over there. Okay. Let's select that's the exercise. I will jump that. Okay. Now, you see, we have been selecting everything. You know, when we did the select star, it returned back everything, both rows and columns in the table, rather. It returned back everything. But then there are times when we don't need that. We only need a subset of all of the data within the table. And that is where the where clause comes in. It says here, the where clause is used to filter records. You use it as a filter to filter out what you don't need, to filter for only what you need or what you want to see. Okay? It is used to extract only those records that fulfill a specified condition. And just underline that, a specified condition. Okay? So now, it says the where clause, this is where we're at. The where clause, you select, and then you can do a star, or you can select, or you can list your columns from the table, and then you put your where, and that is, there's a condition here. It says, please note The where clause is not only used in select statement, it is used in update, delete, and etc. So we use it in the delete and in the update, which we will get to some point. So here we say select star from when we do this, it selects everything 96 record, which is all the records in the customer table. But now we're bringing in a condition, we're bringing in a filter. It says where country equals Mexico. And please note, when your condition, this is our condition, right? When the filter for your condition, right, is text or string as we call it, right? You wrap it around with the what's it called now? The open quotes, right? Open and close. You wrap it around the open and close quote, right? Your word has to be within, in between that the code. Okay, if it is numeric, if it's number, then you don't have to. Okay, so now you see this one returned back. So we are saying that select every column, every row, but only the columns and the rows that has the country, that in their country column, the country is Mexico. That is what we're only asking. So if you come in here, which is here, so it's going to select this one, it's going to select this one, okay? Because we're asking for Mexico and any other Mexico that is in here. That is our condition. So if I execute this, it's only returned back 5. And you can see here that the country is Mexico. Any other country, any other row that do not meet this criteria is not returned. Any other row that do not meet this criteria is not returned. Okay. And then we can do it for Germany. We're doing this again for Germany. Okay. And here it says text field versus numeric field. It says SQL requires single quote around text values, which is what I just explained. Most database systems will also allow double quotes, right? However, numeric fields should not be enclosed in quotes, like I just explained earlier, right? So now you can see you can also filter not just on country, you can filter on anything, right? Any of these other columns. So in this case, we have now applying a filter on the customer ID, and we're only looking for this customer. That's the customer ID. And it's only returning that. That's that customer. Okay. Can you do an exercise for me? Okay, I'll give you 2 minutes. Can you select all records from the city column? Sorry, for all records where the city is Berlin. Can you do that for me? Can you write your select statement for me? And tell me how many rows is returned. Get your hands dirty quickly, roll out your sleeve. Write a select statement with a where clause, city equals Berlin. The first person to finish, give me a shout out. First person to finish, give me a shout out.
I found one.
How many did you get returned back?
I said I found one. Am I right?
No, you write a select statement where city,
Yes, I write
There's
select.
only one
There's only
too.
one I found.
Only one.
only one. Okay, we'll
Yeah.
find out soon. Let's find out. Oops, I jumped up, sorry. Okay, yeah, one. Good. So, excuse me. Okay. You see, when we did our select states earlier, okay, but then we want to see all the customers, right? But then we want them to come, we want to see it by city. Okay, we want to see it by city so that all the customers from one city, they will be listed one after the other rather than now they are in random placement. But we want to have an orderly representation or orderly result set. And that brings us to this keyword, which is called order by. Order by. It says order by keyword is used to sort the result set in ascending or descending order, and the default is ascending order. Okay? Sort it ascending or descending order, but the default is ascending order. So here we do select, right? Star. I'm returning everything from customers. Order by, you see, it's blue as well. It's blue. And then here I'm saying order by country. That is, go to the country and sort the country column by country. So what it's going to do is going to look at the country in descending order or the ascending order. And the way it's going to look at it is going to look at the first character in each of the country, in the first character in the name of the country. Okay, and then when it does that for say UK, Germany, you know, Germany will come before UK because G is before U. Okay, but then within UK, it will also sort the towns and like the city in this case, it will sort the city also in that order as well. Okay, so like in this one, it says select start from country and customers, order by country. In this case, I'm saying sort it descendingly. That is from the highest to the lowest. Ascendingly is from the lowest to the highest. Okay? Ascendingly is from the lowest to the highest. It's going to start, in this case, in country, it's going to start from A to I. But in descending, it's going to start from Z to A. Okay? That's the difference. So if I don't, in this case, if I don't put any sorting order, we call that the sort order. I didn't put any sort order. The engine knows by default that because it says here, it says default is ascending. So the default is going to be ascendingly. If I execute this and I look at the country column, Hold on 1 second. Then I'll call you back. Okay, look at the country. You can see it started from where? Argentina, Belgium, Brazil, and so forth and so forth. And the Venezuela is the last. Venezuela is the last because that's the there's no Z country in here. Okay. And then if I come in here and I now do this, which is I said descendingly, it's going to reverse this. Venezuela will now be the first, and Argentina will be the last. And you can see here, Venezuela is the first, and Argentina is the last. And here you can also do that. We can also specify by the number, the column number, rather than having to even specify the country. So in this case, I'm saying, okay, return back to me the company name, the contact, the title, the city, the country from this. And I'm not saying order by 5, descending. And then this I've specified also, when I've not specified a sort order, mean the default will kick in, which is ascending, right? So in this case, we look at it this way. Number 5, you say you count the column here. 1, 2, 3, 4, 5. Country is position number 5 in here. That is why I don't have to specify country. I can just specify the position of that column in my query, and that will suffice. And then 4 will be my city, so it's going to sort that. Well, let's just do this and see the difference. And you can see here, it's sorting this one descendingly, which is that. But look at here, this is not sorted descendingly. This is sorted ascendingly. Okay, so now when I change and include this, it's still going to be the same. But look at, no, sorry, now you can see, no, sorry, my bad. Come back in here. It's not sorted. It's not sorted. You can see it's not sorted. Right? It's not sorted. It's just like in. And here, when I bring that one, oh, sorry, what did I do? Oh, sorry. And you can see this is also sorted ascendingly. If I now want to reverse this order as well, I can now come in here and specify and say descendingly as well. And then you're going to see this is going to be the first, and then it's sorting it out. And you can see now. Okay, so you can sort, and this is always sometimes necessary depending on what you are trying to achieve. Okay. What is happening here? The product table, which is just the same thing which we have done here, descending, ascending. We're sorting by the product ID, which is position 1, and then by price as well, which is position 4. And I want to introduce another operator, or sorry, another keyword, which in this case is the AND. And we call it the operator, the AND operator. All right, so the AND operator is used to filter records based on one or more than one condition. Okay, like if you want to return all customers from Spain that meets and that starts with the letter G. Okay, let's go do that. You can see here it says select star from customer where country is Spain, and the company name is starting with the letter G. I'm going to explain these filters to you later on. Okay. Okay, so when I do this, it's only returning back where the company name starts with the letter G. When I exclude that, you can see it's returned back 5, but now I have added another condition, which is using the AND operator. And the AND operator, right? The condition that is specified here must be true. If it is not true, then it will return back nothing. It says here 5b. The AND operator displays a record if all the conditions are true. All the conditions must be true. There must be the condition of the country must be true, and also the company name there must be companies that start with the letter G. If there's no country that start with letter G, but there's customers from Spain, then it will return a blank. Okay. So for example, let's change this. I know there's no company starting with the letter Z. Okay. You can see all the conditions are not met. One is met, but the other one is not met. So, and it says here, all the conditions must be true. All of them must be true. But then there's also what we can do. If we are not sure that all of the conditions can be met, but we know that part of it can be met, but not all of the conditions, then there's a way to go around it. And that is by using the OR operator. It says the OR operator displays a record if just one of the conditions is true, then it's going to display that which is true. Okay, it's going to display that which is true. So here it says select start from the customer, where the country is Spain, and the company name is like starting with G, or the company name is starting with what? With N. Okay. And that is true. Every of these conditions is met. Every of them is met. Because why? There's company name starting with G, and also there's company name starting with N. But if I come in and say Z instead, it's only going to return where the condition is true, and where the condition is not true will be, there's nothing to return. So you can see now, it's straight. There's no country that's starting with a letter Z, so not returned, but the ones that start with the letter G is returned, right? And then it brings me to the like operator. The like operator is used in the where clause. Okay, the like operator is used in the where clause, which is like I have used it here, and I've used it here. So it says here, it's like a wildcard. It says like operator is using a wildcard, two types of character. It has to be the quote, and then your percentage, and then you put in your it can be just a letter, it can be a part of a word, right? You can bring in it, and then you can also use the underscore as well to represent one character. It represents just one character, like the D in the and, right? You know, just one character, or if the N that is missing, just to say that one character is missing here, what it is. Okay, so here we're saying select start from customers, where company name like. When we say here, what I'm just saying literally is just like where the company name starts with B, it starts with B, but whatever comes after the B, I don't care. But all I want is that the company name starts with B, and whatever follows, but the condition that has to be met, the like, is that first character must be B, period. Okay, and you can see here the company names start with B, but whatever follows. But if I want to dig a little bit down, I can now say, okay, B, I can say B let's use BOE, for example, and this B is going to return this one, and that's all. Yeah, that's all that it's going to return. It's just going to return that one. You can see it only return that. If I say BL, it should return 2. BL, it should return 2. Yeah, it should return 2. Okay. And when I say just B, and you use this majorly when, for example, you say, for example, you have in your, let's say, for example, in your country column, right? They've recorded the country name in different variants. Say, for example, the country name is, some people are putting in the column UK, some are putting United Kingdom, right? Some are putting U.K, right? So, and you want to, instead of you having to like type out everything, you don't know what variant, you just say, you know what? Okay, I know that we don't have the US, so I don't need to worry about that. I didn't know that you have the UK, it's all European countries, not America. So, but you know the UK has been entered as any of these variants, UK, U.K, United Kingdom, and everything. So you can just go in there and do a filter and say, you know what, where the country name and where the country like U percentage. The country like U percentage. In that case, it's just going to give you all the variants. It's either the United Kingdom, which is starting with U, the UK, which is starting with U, U.K, which is starting with U as well. So it returns that. So that is the kind of scenario where you use the where clause. Okay? And what about you with the employees number? Okay, it says here, it says, write a statement. That was supposed to be an exercise for you guys, but let's go through it together. So write a statement to return all employees who are working in London and are sales representative. Employees working in London are sales representative. I'll throw the question out. Who can tell me how to write that query? All employees who are working in London and are sales representative. Can somebody make an attempt? Unmute yourself.
Hi.
Yes. Mr. Akamali.
Yeah, select
Yeah.
star, that is starts
Yeah.
for all.
Mm-hmm.
From
Mm-hmm.
1 minute, please. Select statement for all employees working in London. Okay. Employees, which is the
Okay.
table.
Yeah.
Employee
Okay.
table. Where
Okay.
where okay, let me look at it because I'm not going to open the table yet. So if you don't mind, let me open the table. Okay, employee.
Where city equals
Where city, okay, I don't know what to call it. Okay, yeah. Where city equals
London,
London.
Okay.
and
You can use and
Mm-hmm.
employee
the
equals
contact title.
The
Contact
contact
title
title
equals
sales rep.
Yeah. Thank you. Okay, so what we're going to have is this, and we're going to have it this way, where city equals, oh, sorry, city equals London. And Contact title. Okay. I'm having this. Yeah. I'm having the weekly line. Contact titles, right? No, wait. Sorry.
Space in contact title.
Yeah, no. There is no, okay, yeah. I think I understand what I was trying to do here. So if you go to the employees table, you have, it should be title. It's title. Okay, it's title from the employees table. Okay, and that's it. Okay. Okay, it says right. Okay, that's still repeating itself. Okay, and then it added another one to it. It says, and courtesy starts with M. So it wants you to expand this query. How do you expand it now? It says, and courtesy of title starts with M.
You didn't tell me you are doing drama.
Hello, can you mute yourself if you are not talking, please?
As per not drama, normal or normal drama.
Yeah. Hello. So what do you think? You only unmute yourself if you are going to talk, and please mute yourself straight back after. So who can tell me what to do next? Question 2. Any ideas?
Same thing to be select staff from employees where city equals to Akuma and what's the column? Title of courtesy like apostrophe percent then then you close city.
Apostrophe
Like
M, yeah, like quote M,
yeah.
percentage M, not M before. If you do M before, that is, you're saying the first letter can be any letter. I will explain that later. I think I'm forgotten that, right? So you now say, and I'll not even bother type it. And then another one, let me teach you shortly. Instead of having to bother to type all the time, you can just come here, click on it, click and hold the mouse on it and drag, right? It brings it to you. And like, okay. Still the same, you can look at that because all of them are the same, right? But then if I want to be more specific, for example, if I want to get the woman out, I can do that. This is just going to return 2. Okay. Okay, it says write a statement to return all employees who are working in Tacoma with the courtesy of that. So all you have to do in that state, with that question, is just change the city to Tacoma. Tacoma. That's all. No, sorry. And you don't need the title. So you just take that out. And there's no city like Tacoma. That's what it means, right? No city like that. If there's no okay. Can we take a break for
Thank you,
all
sir.
right. So done this. Now, see, now we can actually interrogate a database, which is we can select from it, we can filter, and then we can apply further filter by using the and the or clause within here. But then I want to jump. There are times when you're joining more than one table, or you're joining more than one table, which we're going to get to. And also, there are times when the name of the table is wrong, or you want to change the name of a column from what it is, which is for your own, it's going to just be, it won't be applicable to your result set or to your query. It is not going to change the table name or the table column in the underlining table. It will not have any effect. It's just going to be for your own query alone. Okay, and that's why we use the alias. Okay, it says the alias are used to give table or a column in a table a temporary name. To give a table or a column in a table a temporary name. Aliases are often used to make a column name more readable. Say, an alias only exists for the duration of that query. An alias is created with the keyword as, okay? So now look at it. We have in the customer table, in the customers table, we have this ID, customer ID in here, and then we're changing that. We say customer, select customer ID, ID. Select customer ID as ID, and then company name as customer from customers. When I execute this, you see, it's changed that customer ID to just ID, and the company name is changes to customer. Okay, and then sometimes you can the database engine also understand I can write this same thing. See what I'm writing here. Yeah. I can write this same thing, this one here, in a different form, and it's still going to return back the same thing. Okay, and instead of putting as, I'll just leave it that way. And the engine will recognize that I have because there is a gap between this, the name, the first word, and then the second word, and the second word is ended by the comma, meaning that that's the end of this column. You understand that, okay, now there is supposed to be the keyword as here. You don't have to put it, you can, but it's not really compulsory. So far that it is, you end your column the normal way, separation. So in this case, you have the company name, I didn't put an as there, like here, and then I put the customer, it's going to return back the same thing. If I run the two together, you will see, you can see here, still return back the same thing here, the same thing. Okay, so by default, the engine knows that this keyword is here. You don't have to put it. The engine knows. Okay. All right. And then here, I'm changing this one also. Now, this is at the column level. I'm changing the column name from customer ID to ID and from company name to custom. But then I can give the table an alias as well. The whole table, I want to give it an alias. So in this case, I'm saying, yes, I'm still aliasing my column, but then at the same time, I can alias my table as well, which is what I've done here, which is, I'm now saying customer ID, customers table is now represented by the letter C. Or I can choose any name, anything, cost, or whatever. But in this case, I'm just using a letter, okay? And then you can see once I change that the customer, there's a wiggly line. So no, we don't know which table you're referring to here anymore. Because previously I was representing this table with the letter C. But now I've changed that. So if I come and change this one to cost, you see the wiggly line goes away because it's done, okay, this is the table, but this one still doesn't recognize it. Okay, but I will still use my C. Okay, and just the same way, I can also not put us in here as well. And it's still the same thing, just like the one above. And it's going to return back the same result set. You can see? It returns back the same result set. Okay? That is aliasing. So you can alias a table and you can alias a column. Okay? And then this one, concatenation. There are times when I'll use the address as an example. You see, when we store addresses in a table, we do not store most of the time in a very good normalized database. We do not store the address as just in one column. No, you have the house number in one column, you have the street in one column, you have the locality in one column, right? You have the locality in one column. You have the excuse me, the town in one column. You have the postcode in one column, and then you have the country in one column. But there are times when you will need to join all of this together, especially when you're sending a letter. You don't want to put it that way. You want to put it as a proper address. So you can use the key the function which is concatenation, and it's just you stitching columns together. You are stitching columns together. So let's look at this. We say select company name, right? But then we're not selecting address, right? And then we're putting a comma between address and the city, which is the address here is the street, and this is the city, right? So you say 10 Buckingham Palace, London, and then you put the postcode WC, whatever it is, and then plus the country as the address. So, but to do that, you have to use the plus sign and then your separator, which is what is going to separate the address. So you put the plus sign plus your separator, and then you put another plus sign, and then the next column, and then you do the same thing and the same thing as long as you want it. So look at this, how it's going to come out. And now you can see it's brought everything together. So we have Buckingham Palace, London, EC, whatever, UK as the country. And the same thing you have Aubrey Street, 57, Berlin, 12209, Germany. So that's the postcode there. And you can see in my case, I don't have an address. Buhari doesn't have, Joe Biden doesn't have, Denzel Washington doesn't have. So that's why it's returning back those blanks. And you can see here, this one has got the house number, and then the street, and then the city, and then the postcode, and then the country. You see. So we're stitching everything together. All right. And then quickly moving on. Here, I want to stitch two tables together. Two tables. I have one table which is customers, and I have another table which is orders. But then, for you to have an understanding of what we're trying to do, let me quickly do a quick query here. I'll do a select. Okay, now, there are times when you are developing, you will not normally use this when you are writing a query for you are writing a query for a report, okay? But when you are doing your work, your manipulation and all the stuff, you want to see the kind of data you have and stuff like that, you can use these keywords to filter the number of records that is returned to you. But the number of records that is returned to you is there. That filter will not take into account, it will only return the first top rows to you, okay? It's not going to be able to, it's not going to sort it in any other, though you can apply your sort order later on, but when you use this keyword, which is the top, we use top, and then you specify the number of records you want to return. Say, for example, I say select top, and then I open my bracket, I say 1 from customers, and I execute this. It's only going to return to me this problem. Oh, sorry. I need to put in the star. So meaning that I want every column to be returned. If I don't want every column, then I can specify the columns that I want, which I will show you shortly as well. So if I do select top 1, and it's just going to return the first. If I want to select columns, I can now say customer ID, comma, company name, comma, and then contact title. Then I don't need the star anymore. I do if I want the star still, but I don't need it. So I said that, and it's just going to return these 3 columns to me. You can see it's just returned those 3 columns, right? But majority of the time, it is just when you are doing your prep work. So I can select top 1, I can select any number, put in top 10, it's going to return to me the first top 10 rows. Sorry, I need to put in the star. Okay, the first top 10 rows. Okay, so you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I can do the same thing. I want to join to the orders table. Okay, so I have the top 10. So you see, now, what we're trying to do here is we have 2 tables, but these 2 tables are related. Okay, and how do I know they are related? I know I've not taught you this, I've been mentioning about relationship, but can anybody tell me how these tables are related, or what makes these 2 tables related?
I think the customer ID.
So where's the customer ID?
On the table.
Yeah, which of the tables?
Customer and others. Like there's one customer ID, the first column from customer.
Yes, yes. Thank
I
you.
think it's called primary key.
Yeah, primary key and foreign keys. In the customer table, the customer ID, I didn't take you this. So in the customer table, the customer ID is the primary key there. Okay. And in the orders table, the customer ID is the foreign key. Okay. Okay. Let me quickly take this opportunity to take you this. Look at this table here and this customer, and you see here the customer ID column there. It's got a key sign next to it. And the key sign is the head of the key is pointing towards inside, it's pointing inward. That is to show that it is a primary key. And to confirm that, you can see here you have PK. Sorry, you can see here you have PK. That PK stands for primary key. And now let's go to the others table. And you can see also here we have the customer table. Sorry, in the others table, we have the customer ID. And the head of the key is pointing out, meaning that it is a foreign key here. Okay, and it is also confirmation is the FK. So the only primary key on this others table is the order ID column, but the customer ID, the employee ID, and the shipware, they are all foreign keys, meaning that they are primary key in another table, but it is also now represented in this table to create that relationship, to create a link between them, to be able to join the two together. Okay, so what a primary key is one. The primary key is a unique identifier, okay, which is, it is unique for every row in the table. You can see here, you cannot have the primary key here, which is the other ID, says 10248, 10249. You cannot have 10248 repeated more than once. You cannot have it twice. It can only be one because it's a primary key. But a foreign key can be repeated in the secondary table, but in the primary table, it will only be one. So like, look at this, look at this one, for example, right? It is only one time. It cannot be repeated in this place because it's the primary key. It's just like your phone number. Your mobile number is only unique to you. No two people can have your phone number. Your national insurance number, it is only unique to you. In Nigeria, your BVN is only unique to you. No two people can have your BVN, that same number, or your name. It is only you. Okay? But if you look at it also now, that your NI number, right, can be you have your NI number or your BVN. You can use it in more than one bank. Okay, your national insurance, you can open more than one ISA account, because you know your ISA account requires your NI number. You can open more than one ISA account with the same bank. Okay, so it is unique in the parent table, but it can be duplicated in the foreign table. Okay, so like this one is unique in the customer table, and it can be repeated here because here the guy can make so many orders over time. Even within a day, he can make so many orders. Okay, we're going to see that very shortly. So the primary and the secondary is the primary and the foreign key, rather. So that is how you know. The primary key is always the dark one, the light one is the foreign key, and the foreign key is always pointing the way out, meaning that it's coming from somewhere. Okay, but we'll open the door here, and you will see against the column FK, which stands for foreign key, and then against the primary key, you will see PK, which stands for primary key. Okay. So now this is the two tables, but we have already, like we said, the two tables has a relationship, which is this column and this column has created that relationship between them. So I want to see customers and I want to see their orders. I want to see the orders which they have made. Okay, quick one. Christian, I see your hands up. Christian Knight.
Yes, thank you, sir. Just wanted to ask you. Yes, can you hear me, sir?
Yes, I can.
Okay, I just wanted to ask a quick question regarding the primary key and the foreign key.
Okay.
So, do you assign the keys, or is it automatic when you move it?
When you're creating the table, you have to assign it.
Okay, okay.
When we will create one or two tables at some point, and I'll show you how that is done. Okay.
Okay. All right. Thank you.
Okay. And also, let me say also the primary key and foreign key can be in any form or shape depending on what the business rule is. Okay. All right. So the two tables are joined by the customer ID. Okay. The customer ID's presence in the orders table has actually created that relationship, right? So we now want to see, look at this query at the top here. And I want to see the order ID, which is coming from this table. I want to see the order date, which is also coming from this table. I want to see the company that made the order, which is coming from this table. This one is coming from there. So I'm saying, you know, now here I've already represented the column, the tables by C. The customer is C and the order is O. Okay, I'll just choose the first character of the name. So O, meaning that order ID is coming from the orders table. So that is why it's O dot. When you're using the alias in this case, you say O dot order ID, then O dot order date. Then for customer, the company which is coming from the customer, then it's C dot. Okay, sorry. Okay, somebody, okay, the hand is gone down. Okay, so I'm now saying, Jide, can you read the chart for me, please? I can see 7 charts in there. So, this is coming from the orders table. That's what it means. This is coming from the orders table. This is coming from the customer table. I'm now saying from, this is my first table, from customer as C. And then here, I didn't put any word here, but there is a word by default here, which is called join, right? We are going to get to later on. So I'm not saying join orders. So I'm saying that stitch the two tables together. Customer and what? Orders. Stitch them together, right? So that I can fetch, when I say join to you, right, means that, unfortunately, you can't see my hand, I'm just demonstrating it. But so I said join, which is stitch the two tables together, right? And what that does is now makes it a very big table. We're now joining the two tables together in this way, which I will now do. Let me write a query for you. Start from. I want to display that to you. To make it easy for me, I'll do a C dot star. That is, I'm saying select star from this table because I've already aliased this table. If I don't put it this way, there's going to be a conflict. So I say this join And then I'm now telling it which column is joining them on. Which column is it joining them on? Join C dot. Once you do that, that equals, then this column, this customer ID here matches customer ID in the other place. Customer ID. Okay. So look at those two tables. I want to present it as one table now. Oh, sorry, I've not done the right thing. Sorry, I need to put that C. Then I'll do O star. Okay. So what I'm saying is select all the columns on from customer table, and then all the columns from others table. Okay. Now look at it. For you to see, look at this column. That's the customer from the customer table, and that's the customer here from the others table. And if you look at it, they're the same. Look at this, they're the same. The customer ID here is the same as customer ID here. So that is the essence, that is what that relationship does. If there was no relationship, there is no way I can join the two tables together. There must be a commonality between them for me to be able to stitch them together. If there's no commonality between them, I can't stitch them together. So this query above, right, is doing this, the same thing which we have done here, right? It's doing the same thing, but it's only returning back to us just these three columns, and then applying a filter for just this customer. It's the same thing. It's not going to, when I run this, it's not going to return back to me all these rows, because if you look at it, come across, this is where the others table starts. Look at that. This is everything in the others table. And the other side here is everything in the customer table, right? But now it's just going to return to me these three columns, and then apply a filter for where the company name is around the on. Executing this, you see, and that's what it returns back. This is from the others table, this is from the others table, this is from the customer table, right? So that is a join. And this kind of join is called an inner join. It is called an inner join. I will tell you more on joins when we get to joins, okay? All right, so I have an exercise for us.
Pastor Inkasa.
Yes.
Please pardon me to quickly interject and ask a question.
Go ahead, sir.
Regarding what you just explained, which is the join.
Yes.
Yes, it's obvious we're getting information from different tables. My question relates to the order in which the tables appear. So if we look at what you just taught us, select, then you state the columns that are to be selected. Then you say from. If you look at the tables that we are selecting information from, is both from the order and the customer tables. So if you now say from, when you said from customer table, does it matter which table we state first, whether it's from customer table or from the others table that we are selecting them from?
No, it depends on which one you want to first. But the order matters when we are now using our joins. Our full inner join or outer join, which I'm going to come to, okay? Our full inner join or outer join or left join, the order of the arrangement matters when you get there. But for this one, which is just the bare basics of join, you know, here I didn't specify if it's an inner join or if it's an outer join or whatever. I just said, I didn't even just put the join in here, but the system, and if you look at this, it's got a comma next to it. So I'm just saying select, which is what I've written here invariably. But you can see here, I put a comma here as well. Okay. which is the same thing as writing this one. I can rewrite it this way, which is going to return back the same thing. Let me bring my where clause. It's just the same thing. It's just we're now filtering for, we're just filtering now for this customer. You can see, return back the same thing. Right? Does that answer your question?
Noted, sir. Thank you very much.
Okay. Longinus.
Okay, on the alias stuff that you did on the select 0 dot order ID, it's not conflicting. Like you have the 0 it represent the order ID, the order dates. So how is it not picking exactly? Like I'm just confused here. The way you now you just highlighted.
You see, I've explained earlier that you can alias a table as well, just as you can alias a column. Okay. In this case, we are aliasing the table. All right. And here I have said orders, which is my orders table, right, as O. Okay. So if I want to select any column from the orders table, right, I have to specify, because the table. Okay, let me do something. For your understanding, let me do something. Okay, I do a select order ID. Order date. Company name.
The company, there is M in the company. PAMY is M.
And then I say, right? Then I'll say orders, right? Selecting those two tables. But you can see here now that I still have the red wiggly lines, even though you know that the tables are already there. The wiggly line should have gone away, because why? We will have recognized that this order ID and order date is coming from this other table, but it's not recognized in it. Because why? If I do, let me do something again. Take this one out. Select. Okay. Is that company name? Is that the way it's spelled? Okay, let me bring it here correctly. Okay, sorry, I see why that is not happening. It should be customers. You can see straight away it recognizes that. And if I bring in, let me do this one, the other date. Oops. You see here, it is supposed to have recognized straight away. You can see the company name actually has recognized that I'm bringing it from there. Okay, but if you look at it, when you come in, you're not the one that wrote this query. Somebody else did. The person has already left the organization, and you are now the one working on this. You will now be, okay, I have the order ID, I have the order date, I have the company name. From which of these two tables is it coming from? From which of these two tables? And I'll tell you of a fact, because we're still just at the elementary level, sometimes you will see some script. It runs into tens of rows. I remember one of my query that is generating one regulatory report way back when I was in IFDS then. My line of queries was over 4,000 rows. My line of query was over 4,000 lines, right? Okay. And not just select statement like it was a long line, right? Because there was a query within the query within the query within the, so it's cascading. And if you do not put the right nomenclature around your naming, then you are going to cause problem. It is going to be difficult to read. Okay, so in this case, for it to understand, for somebody to come in and see it easily, like this one, you can read this one easily and know which columns come from which table than you can with this one. Because this other ID can come from any table. It's not because this other ID that it does it automatically is from the other table. No. If you go into the other details table here, you will find the other's ID as well. You can see, look at the other ID there as well. Okay, so what we do here is for ease of readability. The ease of readability. So that, okay, you're seeing this, okay, then look at, I come to say, okay, from, okay, see, I know that's customer, oh, okay. So meaning that these two columns are coming from the other table, this is coming from the customer table, that's all.
Okay, I get it now. Like the 0 and C is used to represent the table is coming from.
Yes.
Okay, I was thinking it's just a naming convention.
No. You see, some table names can be also very long. You say, ideally, the way we're supposed to write it, if we do not have this aliasing, it's supposed to be like this. This is the way it is supposed to be. But some table names can be very long. Okay, so instead of having to write it longhand, they gave us the shorthand. Okay, so that's why we do this. Okay,
thank you so much.
So, like I said, this is the same thing as this, and you can see the output. So we're just saying, okay, select this and this. We're joining those two tables naturally without even having to use the keyword join. He knows and he puts him there. Okay. All right. And when you don't want, when I do a comment out, which is this, I select, put that, it's a comment out the selected lines. Click on that, it turns them into green. What it means that though it's here, when I execute this, it will not work because why? The engine will disregard it because it says it is commented that is this query or this syntax is not active. If I try to execute this now, it will return back nothing because why? It's not executing anything. It's once you put this double dash in front of your statement, it comments it out. It inactivates it. Until if you want to activate it, then you remove this line. So if I want to reactivate them, I can either tap on each one and reactivate, or I can highlight as it is and then click on this one, and then it says uncomment the selected lines. Okay. Or if I want to do it individually, I can just come in and do this. Put the cursor at the beginning of that and tap the back button, and then it's activated. And then you can press that dash again. And then if you're going to do the whole lot, you can just do that. Okay. These are just some of the things. All right. It says Exercise 1. Write to select from customer table, selecting the following. You're selecting the employee's full name and address, full address. What are we? I'm not asking you to do, but tell me what we're going to do here for us to get our result set. It says employee's full name and address. And look at the employee. Open your table and see the employee's table. So in the employees table, you have the last name, you have a first name. Okay. But you can see in the employees table, you do not have an address field there. Oh, sorry, this is even a different one. That's a D. You know, the employees table we should also be looking at is this one. Okay, so you have the first name, last name, and the first name, and then you have the address, city, region, postal code, country. So what are we going to do here? To have the full name and then to have the full address.
Concatenate the names, the first name and the last name.
Okay, how are we going to do the concatenation? Just describe.
We will
do a join.
No, that's not concatenation.
I think you would you use the first name or the last name to begin with, then you like plus, there's the plus, then you put your comma. If you need a comma or something, then you add the other column to it.
Thank you. Yeah. So this is how you do it. I'll just show you. Say we have the first name. I will not write the full statement. So you have the first name and the last name. Do you want the first name first or you want the last name first? Depend on you. So in this case, let's have the first name first. You have the first name, right? Plus. And then you have, I want to have a comma separation between them. And then I have the last name. Okay. And then I'll say it as, I'll give it a name, full name. So when I run this, it's going to give me the first name and the last name in one line, as the full name will be the name of the column. Okay, and you do the same thing for the address as well. Okay, yeah, Mr. Ken.
Yes, sir. I have a question regarding that concatenation.
Okay.
Essentially, I know, yes, we are bringing the two feeds together, of course, interspersed by a space. I am wondering why we have the comma inside of the quotation. That quotation to me is supposed to be the space. I would have thought that comma will come outside of.
That comma is not even the space.
No, the quotation is the space.
Yeah, but it is just one tiny space. Just one tiny space. It's not really going to be separation. Okay, let me do it. Let's see.
Let me explain, sir. I don't know.
Go ahead. I just want to show you. Go ahead. Right.
What I am assuming that code represents is the first name plus, then the open quote represents the space plus the surname. I had expected, like I said, that comma, or I had thought that that comma that is inside of the open quotation should come after the open quotation.
No, it is inside.
Okay.
Okay. Because this is where the space is going to be.
Okay. Okay, sir.
Okay. And like I said, this one is not even going to give the space. It is just another. The comma will just be on its own. What's it called? Space, not the space, the gap we are expecting, not the gap, but in its space. Okay. Run this. Look at that. Can you see that? And if I take the comma out, right, and run it this way, you can see. And if I put my comma back, right, and I want space now. Okay, let me run this, and then you see. You see, and I really want, you see, if you don't look properly, you will not see, because it is just the next space. If I want the space now to separate the two properly, I'll put another space in here. And you can see now. You can see the difference?
Yes, sir. Yes.
Yep. So
looking at the results, the result set.
Yeah.
That's the what is now the full name. It has the first name, comma, surname. Would that comma not be should the comma be there?
Depends on what you want. It doesn't matter. I can have it this way. If I don't want the comma there, right? I can have it this way. Right?
Okay. Thank you, sir.
If I don't want the comma there, some will want the comma there, because why? You are separating the first name. Depends on how the usage really will determine how you go the output. Okay, the usage will determine what you're going to do. Okay.
Well noted, sir. Thank you so very much, sir. Thanks for your patience.
Some people, if you see some letter when they write to you, when they use, especially when it's the other way around. If there's the first name, sorry, the last name before the first name, right? They put a comma. Depending on the usage. If they're going to send a letter to you, yes, you can have it like this, right? And in some cases, when it's used in some other application, right, it's your last name, and they put the comma to say that this name, the first part of this name is the surname. Because you know the first name is supposed to come before the surname. But if you're having the surname first, then they put the comma to say this is the first name. Sorry, this is the surname, and the rest is the first name and the middle name, if there is one.
Yes, I have seen that before, sir. When you have the last name come first, the comma should be there.
Yeah.
I've seen it in documents before, really. Yeah.
Okay. Yeah, Mr. Usani?
Oh, sorry, sir. I wanted to clarify that we can actually do the concatenation with the inverted commas and just adding a space.
Yeah.
And that
You
should
see
solve the problem. So you just
this
explained it.
plus
Yeah.
sign.
So you
This
just
plus
explained
sign.
it.
Yeah, okay. This plus sign is what really matters. This is what is joining the two together.
Exactly.
If you don't have the
Yes.
plus sign, if I don't want to have this one, if I don't want to have this one, then I can do this, but it's likely going to fail. Okay, you can see? But because I want the space now, I then have to do a second one, okay? And put whatever I want in between the two. If I don't want, if I want to put the space, even if I do this, right, the system will not recognize it, that I've added the space. Except if I now come in and put the quotes, then you know, okay, now you are separating the two. You join them, but you can want some space between the two while joining them. Okay? And the space that I really want, even with this, is still going to be, it's still going to return like this, because it's just telling, okay, there is a separation. But you've not applied space between them. So for it to happen, then I put the first one will not really make a difference, but the second one will make the difference. Yeah. Puts it that way. If I reduce that, it will reduce You can see. All right. So quickly, any other questions? All right, let's go through the joins. SQL joins. It says joins are used in SQL queries to link records from two. It should be two or more tables based on a common unique key, which is the identifier. It doesn't really, in fact, it doesn't have to be the identifier. There must just be a common relationship, unique keys between the two of them. Okay. Usually, we use a combination of primary and foreign keys to link the tables. Okay. Yeah, that's something which I saw, which I was supposed to mention. Sometimes a primary key can be a composite primary key. Sorry, Dorcas, I'll call you in a minute. Can be a composite primary key. You know, I showed you earlier. Look at this table, our orders detail. The order details table here is a composite primary key. It's a composite primary key. And meaning that there are two columns that actually comes to form the primary key. So you can have more than one column to represent the primary key. Okay. So in this case, let's look at this. In this case, the primary key is unique here. The order table, sorry, the order ID and the product ID. The two of them forms the primary key in this table. Okay, the two form the primary key. You can see, so meaning that it's unique that this order ID plus this product actually forms a unique row, right? Because you can see these two, or in fact, these three orders are from the same customer. I'm sorry, are from the same order, right? But then to uniquely represent each of them, to make them unique, then you concatenate the two together, join the two together to form the primary key for this table. Because if you look at these 42, do I have any other 42 here? I should have another 42. Okay, I think I've seen 72. Look at this one, 72, that is 1028. And I think I've seen another 72 somewhere. Okay, look at this one. So if you have that, say for example, in this table, we just make this the primary key. Then what is going to happen is that it will throw an error that the primary key is no longer unique. Okay, it will throw an error. It says the primary key is no longer unique. And in that case, the purpose of the primary key of that uniqueness is negated. But in this case now, we're now saying, okay, for each product and with the other product on the other list, on the other table, then you join it to that product and then it makes that uniqueness. Because even if that person or that order has bought, say the customer that placed this order, right, places another order after this, is going to have a different order ID, and even when it's buying the same product, will be able to differentiate each of the orders and the products which they bought differently. Okay, so that is why in some cases you will have composite primary key like we have here. So for this, for each order, there must be a product. Sorry, for these order details, there must be an order ID and there must be a product ID for you to be able to write it into this table. If there is no If there's an order and there's no product, then it will not work. Okay, so I just said I should mention that. All right. So now we're back to the joins. It says we usually use the primary keys. It says now we have this inner join. It says inner join returns records that have matching values in both tables. Underline that word, matching values in both tables. Okay. There must be, let's use the customer and the orders table. The customer ID in the customer table must also be represented in the orders table. That means that the customer must have placed an order that is in the orders table for that relationship to work. If we have a customer who has not placed any order, meaning that there will not be an order registered for this customer in the orders table, then that customer will not appear in an inner join. But that customer can appear when we use a left join. We have the left join, we have the left after join, but most of the time we just use the left join. Okay, and says the left join returns all records from the left table and the matched records from the right table. And how do we differentiate our left from right table? That is why I said, somebody asked the question earlier, I said depends on where your, which one is your first table, which one is your second table. Okay, when I'm giving an example, we will look at that. Okay, and then the next one is also the same thing, but it's just the reverse of it, which is the right join. The right join returns all records from the right table and the match record from the left. It's just a swap around. But most of the time, I don't really use right join. I rather use the left join. It's the same thing as the right join, really. So most of the time you'll find the right join, inner join and the left join. Inner join and the left join. Okay. And then you have the full join. Okay. And then the full join, it says return all records when there is a match in either left or right. In this case, what that would do is it's just like you're stitching the two tables together, right? But then, say for example, there are 96 records in the customer table, right? And then you have, out of the 96 customers in the customer table, only 92 has placed an order, and the rest 4 have not placed any order because they are new customers. When you use a full join, it's going to return back all the 92 customers that has placed an order in the in the orders table. So we'll return the customer ID from the customer table and the customer ID from the orders table. And at the same time, it will return the other 4 customers that have not placed orders, but there will not be a matching customer ID from the orders table. That column will be blank. It will return back, so it's going to return back all the 96 customers. Either they have placed an order or not. The ones that have placed an order, you will find a matching ID from the orders table. The ones that have not placed any orders will be blank on the order ID column. Oh, sorry, yeah, on the order ID customer ID column. Okay. Any questions? I couldn't find this. Let me see if I can quickly get something from the internet and show you. There is something which we call, I don't know, those who did additional mathematics, or they call it advanced maths now. If you did additional mathematics or further maths, you will know what is called the set theory. Did anybody remember that?
Yes, sir.
Yeah. This is just where set theory comes in. Okay. I want to see if I can find, I used to have the image somewhere. Let me quickly bring this. And you can see. Okay, you can see this. Which one should I? Okay, look at this. This is even easy. Look at the inner join. Look at my custom flashing here. This is the inner join. This is our table A. This is our table B. And all the rows in table A and all the rows. This is our customer table and this is our orders table. And it is going to return. This green part is the return, and that is where there is a customer ID in the customer table, and there's a custom. That same customer has a row or rows in the orders table when there is a match. Okay, when there is a match. All right, and then the left join. The left join is still our customers, all our customers, and our orders. But then we have 96 customers, but only 92 of them have actually placed an order. So what it's going to do here is going to return back to me all the 96 customers here and only 92 that have actually placed an order. Okay, only the 92 that have actually placed an order. So let's go and look at that now in practice. So let's start with the inner join. We're saying here, give me all the order IDs, right? And the customer or the company name from customer, orders, inner join customers. Excuse me. And then we're now saying on, which is join them on the customer ID from the orders table equals to the customer ID from the customer table. Join it on these columns. So if customer ID 1 is in the orders table, and that customer ID 1 is in the customer table, then return it. It's going to return that. But if there is customer ID 15 in the customer table, and that customer ID is not in the orders table, then it's not going to return it. Only return to me where these two column matches, where there is a match between them. The customer is here, the customer is there. But the customer is in one, is not in the other one, it's not going to return it because we say inner join. So it's only going to return where there is a match. Okay? Where there is a match. Any questions on that? Okay. And I'm doing the same thing, just in a live one. Now you can see I'm now expanding on that as well. I'm not just joining one table. You can join more than one table on the inner join. So, but look at it. There is, I want to see a bigger picture, which is I want the order ID from the orders table, the order date from the order table, and then the customer and the company name, and then the shipper's name. And then I want to see the employee. And I also want to see the ship date and the required date, which is coming from the orders table, and then the freight, which is the amount that was paid, and the country of that customer from the customer table. meaning that I am going from the orders table to the customer table to the employee table, right? So those are the, and then to the shippers table, because I'm looking at the shipper as well. So those are 4 tables I want to select data from, or bring data together from. Okay. So I start with the orders table. And if you come back here, you will see that my orders table has a relationship to all of these tables. You look at, I have the order ID, which is my primary key in the orders table. I have the customer ID, which is a foreign key from the customer table. I have the employee ID, which is the foreign key from the employees table. And I have the ship via, which is the foreign key from the shippers table. And for you to believe that, let me open those 2 tables. You know, you can see that's my primary key from that customer table. Employee, you can see employee ID, and then let's look for the shipper. The shipper is here, and you can see that's the shipper ID, but that shipper ID is named shipper ship there in the orders table. So sometimes the primary key name from the primary table may not be represented the same way. Like in the shippers here, it's called the shipper ID in the shippers table, but when it becomes a foreign key in the orders table, it is called the ship there. So these are some of the things you have to find out as well. You have to understand the table structure and the properties of that table so that you understand what is happening. Okay, because somehow we will look at it, but I can't see the shipper's ID. No, you look at it, it may be named differently, depends on the business rule. So just bear that in mind as well. All right. So I'm then saying select that all these columns from all these tables from my first table is what? Is my orders table. Okay? Is my orders table. So it's now, in this case, it's my left table. And I'm joining it to the customer table. Okay? On these 2 columns from both tables. And then I'm also joining the shippers. I'm not going to join the shippers to my customer because there's no relationship directly between them. They have indirect relationship, and the indirect relationship is it is inherited from the orders table. So, and I say shippers is joined back to the shippers table via the ship via and the ship ID, shippers ID rather. Okay. And then I'm joining also the employees table on the employee ID from both tables. So now I have brought these 4 tables together using a join. If we did not have the orders table that have that relationship with all of these other tables, I cannot write this query. If I don't have the the orders table, I cannot have this query. Okay, so when I execute this, this is a report on its own. And remember, you know, when we look at the customer table, we don't have 92 customers in that table. But look at this result set. We have 831. Why is it so? Why do we have 831? Can somebody tell me? Why do you think this happened?
It appended the rows of the 4 tables.
It's not that.
Of the older
I think
things
because you know, as a customer, you do multiple shopping.
Yes.
Yes, so
Because
I think that's what.
our orders table is the bigger table here. She's just right. A customer can place as many orders as he or she wants, depend on the company. Also now, another thing is, depends on the company rule. The company can say, okay, you can only place 10 orders. And the company can say, oh, there's no limit on the number of orders you can place. Okay? So, and if you go to your orders table and look for one customer, you'll see that that customer will have multiple entries in the orders table, most likely. Okay? So that is why. So it's returning back everything. So now, if you want to do a filter to just see, let's look for King Charles now. It doesn't have any order. But let's look for, which customer ID can I look for here? Let's look for one. Oh, I will see the customer there. Let me bring the customer. Okay, let's look for these. Well, let's look for this customer. That's it. So you can see the dates of the order. 1997, 97, 97, we get that. 98, 98, 98. So that's a 3 in each year. And then you can see the sum. Oh, yeah, no, the cost of freight. This is not even the orders this is just the cost of freight. I can expand this also if I want to now bring in the product, if I want to see the product. Because the products are not, the product for this order is not recorded in the orders table. The product is recorded in the order details table, which is this table. Okay, so if I want to bring that in, let me expand this. So I want to bring in the order table. So I'll now bring in inner join. I call this OD, order details on OD dot order ID equals yeah, okay. Sorry, O dot order ID. But because I want to see the product name, I need to do another join. So, which is now going to be inner join. Because when I do this, I won't see the product name because I can only see the product ID here. So I won't be able to access the product table. But I need to now join it back to the product table. I'm joining into the product table. It's P on OD dot product ID equals P dot product ID. So in this case, I've joined more tables to this. So I want to see the product. So I want to see, let me see the dot unit cost. Sorry, I want to see the quantity. I want to see the I've seen the quantity. I want to see the unit price, the quantity. I want to see P. I want to see the product name. Okay. So this is now a different result. Okay. And now you can see this is the quantities and this is the unit price. And that's the product name for each of these order. And now I can do something on the fly, which I'm jumping, but no worries. I can do something on the fly, which is now, I can do a data transformation on the fly. Here I have the quantity, I have the unit price. So what is the total sales? What is the total amount? I don't have it, but I can generate that. And that is one thing in databases to save space. You do not need to enter